Hello everybody, here I am again, and today we are going to discuss about binary ionic compounds and binary covalent compounds. So we're going to start writing chemical formulas of these compounds, starting with binary ionic. So when you say binary, it is actually composed, it's a compound which is composed only of two elements. So just like this. Now why is it called as an ionic compound? Because it is composed of a metal and a non-metal, just like the examples given to you. So let's try, for example, name all these three chemical formulas based on the elements present. So in naming binary ionic compounds, first you have to name the first element in the formula. The first element is Na, which is our sodium. The second element is chlorine. You name the second element, but it should end with IDE. So that will become chloride. So the first chemical formula or substance is our sodium chloride. So how about the second one? Name the first element. Mg is magnesium. The second element is Cl, that is chlorine, which should end in IDE, so that is chloride. So MgCl is named as magnesium chloride. This one, name the first element. First element is calcium. Second element is C, which is carbon, but it should end with IDE, so we can have it as carbide. So Ca2C is calcium carbide. How about if the name is given, and how would you write the chemical formula? So for example, you have aluminum oxide. So it's between aluminum with a symbol Al and oxygen with a symbol O. So you need to assign charges. Where are you going to get the charges? So these are representative elements, aluminum and oxygen. So you can immediately see and get the charge from the periodic table. So Al is from family 3A, it's a metal. The charge is positive 3. Oxygen is from family 6A, which is a non-metal. It should gain 2 electrons. That's why the charge will be negative 2. So we're going to perform crossing over of charges. So crossing over of charges will give you Al, then you give the 2 of oxygen. No more charge. It should be in absolute value. So that's going to be Al2. And then the second element is oxygen. Then you give the 3 charge of the aluminum. So Al2O3. That's our aluminum oxide. How about this one? Potassium is written as K, and you have sulfide or sulfur as S. This is family 1A, a metal. Charge is positive 1. This is from family 6A also. 6 valence electrons, which would require 2 more electrons to become stable. That's why the charge is negative 2. Crossover of charges. Crossing over of charges will give you K. Then you give the 2 of the S. That's K2. Then S. You copy the S and then give the positive 1. We don't need to write 1 anymore because the symbol S already represented 1 atom. So how about magnesium fluoride? So magnesium is written as Mg. You have fluorine as F. This is on family 2A. From the periodic table, the charge is positive 2. This is fluorine from family 7A, which requires 1 more electron to become stable. That's why the charge is negative 1. Now, crossing over of charges will give you Mg1, but we're not supposed to write anymore the charge because the symbol itself signifies 1 atom already. And then copy the F and then give the 2. So that's going to give you MgF2 or your magnesium fluoride. Now this time, let's try to have naming and writing chemical formulas of binary covalent compounds. Now what are these covalent compounds? These are actually compounds which are also composed of 2 atoms, but this time they are both non-metals, just like carbon and oxygen, nitrogen and hydrogen, and the rest of the examples given. So when you name binary covalent compounds, you have to make use of prefixes which could represent the number of atoms in a given chemical formula. So let's try, for example, the first one. You have a carbon and oxygen combination. So when you have a chemical formula like this, you can simply name it as carbon. The first element is carbon and the second element is oxygen. So that means you have one oxygen, so you can make use of the prefix mono for oxygen. Okay, so we did not make use of prefix mono on the first element because it's supposed to be used only on the second element and not on the first element. So that's why you have only mono on the oxygen and not on carbon. Let's try, for example, the second one. You can immediately name it as carbon. And the second element is oxygen. You have two atoms of oxygen. Prefix for 2 is di. So you have dioxide. Take note that the second element should always end in IDE. So let's try to have the third example. First element, you have only one, nitrogen. So again, do not use the term mono, prefix mono on the first element because it's supposed to be used only on the second element. The second element in here is hydrogen. You have 3 hydrogen. Prefix for 3 is tri. So you can have trihydride. How about this one? You have 2 phosphorus, so prefix for 2 is di, so you can write it as di-phosphorus. And you have 3 oxygen, that is trioxide. How about this one? You have again 2 atoms of phosphorus, so you can write it as di-phosphorus, di, which means 2 atoms of phosphorus. You have 5 atoms of oxygen. Prefix for 5 is penta, so it's supposed to be pentaoxide, but it's a rule that when A is followed by O, then omit the A and go immediately to O. So you can simply write it as pentoxide and not pentaoxide because we have omitted already the A of the prefix penta. So for example, chemical names are given. How would you write chemical formulas? So pay attention to prefixes. What element is this? Nitrogen. So nitrogen. How many nitrogen? Di. Di means 2. This is trioxide. Oxygen. How many? Tri or 3. So you have 3. So N2O3 for dinitrogen trioxide. How about this? Only 1 sulfur and then oxygen. How many? Di. Di means 2. So that is SO2. Oxygen. Only 1 oxygen. Difluoride, which means you have 2 fluorine atoms. So OF2 for oxygen difluoride. So that's all for today, folks. I'll see you again next time. You can subscribe to my channel for more common chemistry videos. Thank you.